Alright, today we look at another useful form of linear equations, and this form is called the point-slope form. So first I'm going to give you the formula, and then we're going to go about by writing equations in slope form. So here's the formula. So we have that y minus y1 is equal to m multiplied by parentheses x minus x1. Now here y1 and x1, those are the coordinates to a point on the line, and m is going to be your slope. And you're going to see that it's very useful in getting the equation of a line, and also if you'd like to graph a line, this is also helpful. So let's take a look at an example here. So it says, what is the slope and what are the coordinates of the point x1, y1? So in order to do this problem, I'm going to make use of this skeleton right here. So let me rewrite it for you. We have y minus y1 is equal to m parentheses x minus x1. So now here I'm just going to match all of the variables to the numbers in the equation that we were given. So if we look, y1 here, that's the same as my 4. X1 is the same as my 6, and then m is the same as my negative 2. So for this problem, we're going to say that m is equal to negative 2, x1 is equal to positive 6, and y1 is equal to positive 4. And I can write these as a coordinate 6, 4. Let's look at another problem here. So now we have y plus 3 equals negative 5, x minus 3. So in this problem, I'm going to actually rewrite this equation right here. So I'm going to make use of the fact that two negatives, when you multiply them together, you get a positive. So here, rewriting the positive 3 as negative is the same thing. And you're going to see in a minute why I decided to do this. And now we have negative 5 x minus 3. So if I get the skeleton, we have y1 minus, it should be y minus y1 equals m x minus x1. And now here, notice that this skeleton, the formula or the recipe here, only has subtraction, and the one that we were given, we only had addition here, so we had to translate this so that we could read this formula here. Now we can match the y1 to something, which would be this negative 3. So here we get that m we can match it with negative 5, and then x1 we can match it with positive 3. So here we have m equal to negative 5, x1 equal to negative 3, and y1 is going to be matched to negative 3 as well. And this one's supposed to be positive 3. And we have the point 3, negative 3. So we can do the same thing here. We can rewrite this as y minus negative 1 equals 1/2 x minus negative 2. And now we have the general equation y minus y1 equals m x minus x1. And now I'm going to match everything. So y1 matches with negative 1, m matches with 1/2, and then x1 matches with negative 2. So I have that m is equal to 1/2, and then my coordinate x1, y1 is equal to negative 2, negative 1. Alright, let's try one more problem. So here we can write this as y minus, we already have a minus here, so there's no need to do something fancy. We have 0.5. And now here, since we have a plus, we can rewrite the plus 3 as minus negative 3. And now our general equation, I can sketch it out here. And now we can match everything. Y1 matches with 2, m matches with 0.5, and then x1 matches with negative 3. So my slope is going to be 0.5, and my coordinate x1, y1 is going to be -3, +2. Alright, so now a lame interpretation of this would be, well, in order to get your coordinate x1 and y1, would just be to get the opposite values of these ones. So for example, here I had a -2, so my y1 was a +2. Here my x1, you can think about it as being a +3, so here I wrote it as -3. But it's but if doing that defeats the whole purpose of learning how to understand the algebraic process of manipulating an equation, and it's a lot more powerful to understand what you're doing as opposed to just following a procedure. So hopefully you understand this rather than just well, noticing a pattern, which noticing patterns are also important, but here the importance really is learning how to play with equations and manipulating things.